So in this video, I'm going to start my series on Electrical Engineering 1. I will start with charge, current, voltage, and power. So, what is charge? Charge is atomic particles. A lot of atomic particles put together, and it's made up of electrons. We all know that one electron is equal to 1.602 times 10 to the 19 magnitude. So there's a magnitude of that. So how do we find the number of electrons within 1 coulomb? The number of electrons within 1 coulomb is just 1 coulomb divided by that magnitude, which will give us the number of these within 1 coulomb. So 1 coulomb is equal to that, which is equal to 6.24 times 10 to the 18 electrons. That's basically all on charge, except for the law of conservation of charge. So what is this in circuit theory? Well, in circuit theory, this means that the sum of all the charges within the circuit must equal 0, because whatever charge goes in must also come out. So if I have a circuit with an element like this, whatever element it is, it doesn't matter. And we have another element here. Let's say this element outputs a certain charge, then this element over here must use all that charge. So current. Current is the flow of charge that we just did over a certain time period. So it's the flow of charge over a time period. So we define current as I. We define charge as Q. Sorry, I forgot to say that. So this is charge from there over a time period. So if we write this in formulae, we know charge is Q. So the change in Q over a certain time period. We define time as T. The units we already said for this is coulomb, and for time is seconds. And we can also rewrite this as a derivative because it's the change in this over the change in this. So it's a derivative of Q with respect to time. And the units for current known as amperes. So many amperes. We can also put this within a graph format because we know that this is the change in Q over the change in T. So the change in Q over the change in T. So what does this mean in terms of a graph? Well, it means that current is the gradient of this curve because it's the derivative with respect to T, the derivative of Q with respect to T. Okay, we can also manipulate this formula some more. So if I rewrite this, the one I just derived, we can say, okay, well, how can I get Q on its own? So that we can, in certain cases, work out Q. So we can say, okay, well, this is being derived with respect to T, so I can also integrate with respect to T to get Q on its own. So that would mean that the integral of I dt would be equal to Q. And we can say, well, we drew a graph of this, so we can also draw a graph of this. We're integrating I with respect to T, and that is equal to Q. So we're integrating I with respect to T. So what does this mean? Well, if I draw a curve here, any curve, then Q will be equal to the area underneath the curve because an integral is the area under the curve, just like a derivative is the gradient of the curve. So that is Q here, and that is I there. Okay, so then the next part we look at is voltage. Voltage, variable V, defined as V, work done moving charge Q from point X to point y. So the work done, if we read this definition, work done moving charge Q from point X to point Y. So how can we write this in a formula? Well, the voltage XY is equal to the work done for some unit of charge, Q. So the work done, we define work done as W over change in Q. You can also rewrite this as a derivative of the work done with respect to Q. So that's voltage. In terms of polarity, polarity is the fact that there can be positive and negative voltage and that it can vary. So if I have point X with an element linked to point Y, then the one side must be positive and the other side must be negative, but it can vary. It's not necessarily the fact that that side is positive and this side is negative. It can also be the other way around. So just take note of that. So over an element there would be a positive voltage this side and a negative voltage this side. Okay, so next we look at power. And then some basic circuit elements, which you should know. So power is the rate, let me just get this page straight, rate of the element losing or gaining energy over time. Okay, so it is the rate of the element gaining or losing energy over time. So we just said that energy is defined as W. So change in W for energy over the change in time, which would give us the derivative of W with respect to time. And now we can say, okay, well, how can we define power in terms of voltage and current? Because we might not always have the energy and the time. So it would be more convenient to have voltage and current as elements within the power formula. So now I say, okay, I look at my current formula. I can see it's the change in Q of the change in T, and I can see voltage is the change in W of the change in Q. So if you look here, there's change in W and there's change in T. Change in W, change in T. So the same elements appear here and here, except for Q and Q. So if I multiply by Q over Q there, then I will get these two multiplied together, and I'd be multiplying by 1. So I wouldn't be multiplying or doing anything illegal in terms of multiplication. So that would mean dW dt times dQ over dQ, which would give us, if we just move this around, then all I did was move that underneath the dW, and then I'm going to move the dt under that dQ. And this, as we can see, that dW dQ is dW dQ, which is our voltage, and dQ dt is dQ dt, which is our current. So that is V times I. So that is how we derive that formula, and this is simply the theory video, so this is just simply going to be used as it is. You won't have to derive it every time. Something else about power is the sum of all the powers in a circuit is equal to 0. Just something to note. So now we're going to look at a quick example. So if I have a circuit element, and like we said, we can have voltage over it, and I'm going to define the polarity that way. And if we say we have a current of 1 ampere flowing this way, they usually show it with a small arrow, but you can add a bigger arrow in just so it makes more sense. So in terms of polarity, this is important because this is going in at the negative terminal, please note, of this element, which means you have to take that into account. So if I'm asked, please calculate the power in this circuit, we use our power formula from here because we're given voltage and we're given current. So we say P equals V times I. And we say, okay, which side is this current going in? Well, it's going in at the negative terminal, which means it's minus of whatever that is. So minus 1 volt times a current of 1 ampere, which is flowing in there, which is equal to minus 1 watt. I forgot to say the units of power is watt. Haha, what? Okay, then we're just going to look at some basic circuit elements. We're going to be looking mainly at active elements. You also get what's known as passive elements, but that is not important right now. So you get independent sources. Independent relating to the fact that it's not reliant on any other element in the circuit. It will give what it's giving without anything else in the circuit being there. So what is that? That is a voltage source which provides some sort of voltage. We draw it like that, positive, negative. It can also go negative, positive, the other way around. So just take note of that. And then we define a current source which provides a current. So I'm going to say this is 5 volts and this is 1 ampere. And the flow in this case is that way. It can also be drawn like that. Just like this can be redrawn like that. So if you're looking from this side, this would be positive, that would be negative. The current flows this way is 1 ampere, but this way it's -1. So please take note of that. Okay, those are your independent sources. Then you get what is known as a dependent source. Dependent sources, well, they depend on something within the circuit, something else, in order to work. And if that something else isn't there, then they won't work. So you get 4 types. You get 2 types of dependent voltage sources and 2 types of dependent current sources. Types of dependent voltage sources, well, it can either depend on another voltage or another current. So we name them as voltage controlled voltage source, which means this is a voltage source and is dependent or is controlled by another voltage. You can also get a current controlled voltage source, which is this voltage source is controlled by another current. Then you also get the same with current sources. So the current source is controlled by another current and the current source is controlled by another voltage. So just to take away any confusion, let's look at a quick example of this. If I have an element B and I have a dependent current source here, and the current that it puts out is half of VB. Okay, so this is here VB, sorry, defined like that. So if the voltage over this is VB and this puts out half of VB, then this is a current source which is controlled by this voltage VB. So it's a voltage controlled current source because it is a current source controlled by this voltage VB. That is all for circuit theory. Please check out my next video for a few examples